Schlegel coming at you with the week 3 homework assignment for Math 94. With that, we're going to get right into it. Number 1, we've got to use less than, greater than, or equal than symbols to compare the numbers below. And if you remember from probably elementary school or something, the alligator eats the bigger number. And so with this first one, if I can stay on the page. What we're going to have is 98 is greater than 92. So it looks like that. 89 is greater than 9. 149 is greater than 82. And last but not least, 788 is greater than 557. Pretty simple on that one. Next, we got some rounding to do. We're going to round to the nearest 100 on this one. So we're rounding to the 3, which means we need to look at the number after the 3 and ask ourselves, is that number 5 or is that number less than 5, or is that number 5 or larger? It's a 6, so it's larger than 5, so we need to round up, which is going to make this 4,400. Next, we need to round to the nearest 1,000. So we are rounding to the thousands place. We need to look at the number after it. That number is less than 5, so we need to round down. So that's going to leave us with an answer of 1,000. Pretty easy for the first page here. Let's move on to the next. Now we get something that's quite nasty in comparison to what we just did. It's an order of operations problem, so I'm going to make sure to record the order of operations here on the side. We first need to do parentheses, exponents, then multiply or divide from left to right. Multiplication and division will happen from left to right, not always multiplying before dividing. Addition and subtraction will also happen from left to right. So with that, let's look inside parentheses first to see if there's something that we can do. I'm going to rewrite this problem so that I'm just going to. So when we're looking inside parentheses, we sort of have these brackets. Those can be considered parentheses. And then inside the brackets, we have parentheses. We always want to work from the innermost set of parentheses. And so we are going to be starting inside these parentheses right here, because those are the ones that are what we call nested inside the other ones, or the ones that are most to the inside. So I do see that I've got 11 minus 9, and that's going to be 2. Everything else is going to stay exactly the same. Please do not be lazy and skip writing down the next stuff, because your brain can only process so many things at once. When I do math, you will always see me only doing one step at a time, and I will rewrite the entire line, because I don't want to make a silly mistake because my memory failed me. So now we are still working inside parentheses, inside those brackets, and we need to look for any exponents. We don't have any exponents. We need to look for any multiplication or division. And I do see multiplication right here, this 3 times 2, so that's what needs to happen first, even though it's on the right. So we've got 42 divided by 1 plus, and 3 times 2 is 6. So again, just one step, and I rewrite the entire thing. Next, we are still working inside parentheses. The only thing left to do in there is add the 1 and the 6, which is going to be 7. And then I don't need to write those parentheses anymore, because they would just be holding one thing inside there, and so I don't need to write them. If you do choose to write them, like I'm doing in green here, that's okay. You still have 42 divided by 7, which is going to be 6. And if I don't write them, I still have 42 divided by 7, which is going to be 6. Either way, my final answer is 6. Moving on to number 5. Similar in that we have an order of operations problem. So again, I need to do parentheses, exponents, multiplication or division from left to right, and addition or subtraction also from left to right. So we do have 9 squared, so I've got some exponents, minus 3 times 5 plus 6 squared. So again, I've got exponents. And so we are supposed to do the work inside parentheses first. So let's do that. We will have 9 squared. And you could write 81 right here if you wanted to, because it's not going to affect other things. I'm going to stick really hard to the order of operations here just to hopefully avoid confusion. I need to do the exponents inside the parentheses, and so 6 squared is the same as 6 times 6. I'm just going to write that out like that so people can see in the video here. But 6 times 6, 6 squared is going to become 36. Maybe I'll write it off to the side. So that expanded out is 6 times 6, or 36. Okay, hopefully that helps clear things up a little bit. Next, still inside parentheses, we need to do any exponents. We don't have any anymore, so we need to do any multiplication or division from left to right. So I will choose to multiply my 3 and my 5. I will get 15 plus 36. Next, still inside parentheses, I've got 9 squared minus 51. And again, now that I'm down to one term, I don't need those green parentheses anymore. You could leave them on if you really wanted to, but you don't need to. Now that the parentheses are gone, I'm going to jump down to my next, which is exponents. So I do have 9 squared, which is going to be 9 times 9, which is 81. And so I'll show that jumped out here to the side also. And I will have 81 minus 51, which is going to give me 30. Now your steps getting to the final answer may have been different than mine. There's a couple different ways, because this problem is sort of unique in terms of there's a couple different ways that it could be done, but you would still end up with 30. So if you don't end up with 30, you need to do something different than you have so far. Next page, back to some pretty easy ones. We are looking for all of the prime numbers. So a prime number is a number that is only divisible by itself and 1. And so with that, as we go down this list, we'll be looking for numbers that can only be divided by themselves and 1. So starting us off, we've got the number 2. The number 2 can only be divided by itself, which is 2, and 1, so it's prime. 4 can be a product of 2 times 2, so it is not prime. 11 is only divisible by itself and 1. And so for these where it's not prime, I'm going to give an example. So I can put an example in here, 2 times 2. 15 could be 3 times 5. 20 could be 4 times 5. Or 21 could be 3 times 7. So that's why those numbers are not prime, because they have more options to create them through multiplication than just multiplying the number itself by the number 1. So the next one has 2 possible options at least. I'll separate them out here. There may be more than one option, but or more than 2 options, but I don't think that there is. So we are asked to completely factor 63. And so when we say completely factor 63, we mean divide 63 as many times as we can until we get down to only having prime numbers at the bottom of our little tree here. So 63, the first way that I'm going to think about 63 is 3 times 21. Now 3 is prime, so I can't factor that one any further. But 21 can be rewritten as a product of 3 times 7. Now 3 is prime, and 7 is also prime, so that's the end of my factor tree. So my product to get 63 from these numbers is going to be all the things I circled in green. So 3 times 3 times 7 would equal 63, because 3 times 3 is 9, and 9 times 7 is 63. Option 2 for 63, we are going to have 9 times 7, and we're going to see that 7 is prime. So we're going to leave the 7 there. And we know that 9 can be written as a product of 3 times 3. And 3 is prime, so both of these are going to be a stopping point for us with this. And my 3 factors, again, are 3 times 3 times 7 equals 63. So 2 possible routes you could take to doing that one. You're only required to do one. I just wanted to make sure I showed both for people who chose one way or the other. Then the greatest common factor of 18 and 45 is going to be the largest number that 18 and 45 are both divisible by. So I'm just going to make a list of factors for 18 and a list of factors for 45. We'll see what the biggest one ends up being. So for this, I will have 1 times 18, and I just count up. So I'll try 1. 1 times 18 works. 2 works, it's 2 times 9. 3 works, it's 3 times 6. 4 does not. 5 does not. 6 I've already got, so I can stop. As soon as I get to a number that is being repeated, I know I'm done. So for 45, I'm going to have 1 times 45. 2 does not work. 3 does. It's 3 times 15. 4 does not work. 5 does. It's 5 times 9. 6 does not work. 7 does not work. 8 does not work. 9 does, but I've already got it, so I know that I can stop. So now we're going to go through and circle all of the numbers that they have in common. They both have a 1. They both have a 3. They don't both have a 2 or a 5 or an 18. They do both have a 9. And they do both have only one of them has a 6. So those are all of them that match. We're looking for the biggest one. And so because we're talking about the greatest common factor, the biggest or the greatest common factor among these is 9. Again, it's the largest number that I could multiply something by to produce 18 and 45. And lastly, we are looking for the lowest common multiple of 8 and 10. So lowest common multiple, often called the least common multiple as well. To create that, what we're going to do is just multiply this thing, multiply these numbers by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever, until we get a pair. So 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. 8 times 6, I'll go up to 10, is 48. 8 times 7 is 56. 8 times 8 is 64. 8 times 9, 72. And 8 times 10 is 80. Now, if I go and make my list of 10, and I don't have a pair, by the time I get down to 10, I need to keep going. So we'll take our 10, and we'll see what ends up happening. So 10 times 1 is 10. 10 times 2 is 20. 10 times 3 is 30. 10 times 4 is 40. 10 times 5 is 50. 10 times 6 is 60. 10 times 7 is 70. 10 times 8, 80. 10 times 9, 90. 10 times 10, 100. So now I just need to go through this list and find any numbers that are common. So 10 is in the green but not the blue. So is 20, 30, 40 is in both. 50 is not, 60 is not, 70 is not, 80 is not. Yes, 80 is. My bad. 80 is in both. So now what we need to look at is which one of these is the lowest. It's going to be 40. It's the lowest one that they have in common. Okay, so that's going to be it for the week 3 written homework. I hope this video finds you well, and I hope you have an awesome day.